Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Howick Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, howickltd.com. Brought to you by Graitec, one of the largest Autodesk partners globally and software developer of the Powerpack Advanced Design, Advanced Steel, and the StrucSoft product line. The complete solution to automate wood and light gauge steel framing, design and documentation, all the way out to CNC output, model, design, and manufacture with StrucSoft. Learn more at strucsoft.com. We are at the Red Block Systems manufacturing facility. What is the value of a red block? We're going to get into all the 10 properties that make red block a better way to build. Let's go. Hey everybody, I am sitting with Markus Pichler, and we are going to talk about the Red Block system. Markus owns Red Block Building Systems, and there are manufacturing facilities all throughout Europe that are using this system. And it all starts with this porcelain clay block right here, and you turn this into a full automated one, a full automated factory, but you've also turned this into a complete wall building system.
Correct.
Tell us a little bit about your background, Markus, and how you got into this.
I'm brick maker in the 6th generation now,
Yeah.
so we're doing that business in our family for 243 years now. The 7th and the 8th generation. 7th is already in the plant and in the company. 8th generation is already made, so I'm convinced that we have a good future in front of us. To answer your question, the brick is our core business. This is where we're coming from, and we learned that in the last 2 decades, we learned that prefabrication will be also for our industry a very big issue.
Yeah.
And we are thinking in long terms, so of course I was convinced that if the brick does not find a solution and an answer for prefabrication, our branch will have troubles in the future. And that was the reason that brought me to the decision and also to the point where I said, okay, I have to find something and I have to invent something, because there was nothing on the market that was meeting my requirements and my ideas. So we started really from first scratch. We built up a complete new way of building, completely new, and we broke a lot of rules, brought a system on the market which started in 2003, 2004. Then we had to do a vast certification process because, as I said, we broke rules.
You broke the rules from what was in the standard code and created something new.
Yeah, because in our building codes, a masonry consists of a building block.
Yeah.
Maybe it's either ceramic brick or it's ASC or whatsoever, and a mortar.
Right.
And what we took out of the system was the mortar, and instead of mortar we used an organic glue. And that, of course, was written in no standards, so we had to do the whole process and get through that. That took some time, and as I said, we even invented all the machineries because also those were not on the market. We brought in our new ideas, and we took a lot of risk doing that. But at the end of the day, we developed a very intelligent system that can build almost everything what you can build on the construction site with solid mineralic building materials. Of course, as we invested quite a bit of money, somehow you have to get a return on that. So my idea always was that I would like to multiply that, what I'm doing here in Wels, that we multiply that, and we are doing that by licensing our system. So this is a protected system, which is based on the kind of glue, and of course on all that big research work that we did to get it standardized.
Sure.
This is our asset, this is our know-how. We have 10 licenses in Europe and 1 in Russia that are producing according to our system. And it was hard the first, let's say, 10 years. It was really hard to get into the market because we had to convince also our clients that this is a new system, this is different. You know, the construction industry is very, very traditional. New things are not adopted very quick, so it takes a long time. But finally we made it, and right now we are on a very, very good path. You know, we sold 4 lines the first 15 years, and now another 6 in the last couple of years. And we have a couple in the pipeline so we are working on projects now, which 1 in Austria, 1 in Romania, and 1 or 2 in Kazakhstan. We are also on the Ivory Coast in Africa for cheap housing, because they have a huge demand down there. We even got now the certification for the French market, so we try to bring our food there also on the ground. And we have a very close look at the UK market, which is, you know, UK also, my feeling is the UK market is pretty much like the American market. So in terms of standards and certifications and stuff like that, correct. The UK market for us is in the focus, and of course, as I already said, the American market, which is a huge market, also very interesting. But, there is always a but, we need the right product for our system. And the right product for our system is a monolithic building block as big as possible and grind it to an exactness of 0.2 millimeters.
Here's a sample of the block sitting here. You know, let's kind of get back to this. And I mean, you've been building this way for a lot of years with just the block. You told me a story that you went to the auto manufacturer, I think it was at Audi, and you saw them gluing together metal
plates,
and you were asking them why, and I'm going to
why they're not welding it.
Why are they not welding it, right? We always weld metal. And then he made a comment that, well, all the planes you've been flying in are all glued together and not welded, and that's what gave you the idea for building the block walls. Now, this is a heavy, you know, it's a heavy block in theory, right? Like, how do you glue something together? But that's where you mentioned about the grinding. And you get these within a 0.0 millimeter of a difference, which then allows it to have a full level contact for the glue.
That is essential.
And it makes it as strong as anything you could ever put up out there. And now you're doing big wall block systems. And not only that, you've automated this system to where your manufacturing brings in the raw material, and from that moment that raw material is brought to the plant, a human does not touch it again until these are actually being installed on a job site. So the manufacturing of the raw material happens, the mixing, I call it the spaghetti printing of the brick. You'll see what I mean on that. And then also the assembly of the wall systems is all run by 3 people in the manufacturing facility. Now, let's not take away from all the people in the office that have to make this happen around the world. Did I summarize that right?
Yeah.
And you were the first one to bring robotics into this space.
Into the brick industry.
Into the brick industry, and that says a lot. And the forward thinking. And you also told me that everybody thought you were nuts.
Yes, because nobody thought that this is going to work.
Right.
Because brick plant is not like a clean room. It is, you have some dust and yet some temperature. And everybody said robots are not going to stand to that. And they proved from the first beginning, they proved exactly the opposite.
Sure.
It's just perfect.
Yeah, and there's some other things happening too in the world. You know, doing the kiln and the heating process. There's a whole lot of natural resources now being looked at and will be launched probably on this show next year on how to reduce the carbon on all of it, the manufacturing, and we'll get into already the carbon reduction on site a little bit later in this conversation. What's interesting to this about me, when you take a block wall like this and you build it, people think mass and heavy, which it is. But if you do traditional panelized construction or modular, it's mass and it's heavy. You're lifting both, or all three of them with cranes, no matter what you do. This just has a lot of inherent properties built into it. And that's what we want to talk about today. There's a lot of environmental benefits to this system that you do not see in other systems of building.
Building physics advantages, environmental advantages.
Yeah.
You have the brick has a lot of advantages, and it is let's say, the healthiest material you can live in. Brick gives you the best room climate from all building materials.
Yeah.
That's a matter of fact, because of its ability. First of all, you have mass. You mentioned the weight of the brick.
Right.
Mass is also something that holds warmth or also cools. That is, as a matter of fact, one-family houses or multi-family houses here don't have air conditioning. We don't need it.
Yeah.
So the only energy that is used for our houses is for heating, but not for cooling.
Right.
And if you look at America, I've seen a statistic that says you're using more energy to cool down the buildings in the United States than you use for heating them. And that tells a lot. And energy is a limited resource, which is, we got it,
right.
We learned it the last 2 years. It can raise in price like hell, and that can be a killer.
And it can happen too. We were talking offline. You said the electricity cost last year went up
3,000%.
Can you imagine if your energy bill went up 3,000% in 1 year? To sit here and think that that can't happen to us is foolish, and it could.
But it happened here.
The properties of the brick, right? You guys say it's a 10-in-1 system.
Correct.
And I was saying 3-in-1. He said, nope, 10-in-1. I said, okay, and I'll tell you my 3-in-1, and then we'll get into the 10-in-1.
Yeah.
Right. But the way the bricks are developed with the open air cavities in them, there's several different models of this for different purposes, but you want to end up with a natural vapor barrier that not only helps with moisture control, it balances the moisture from the inside and outside of the home. That's one. So there's no air barrier or vapor barrier that's needed for the exterior of this product. Two, because it has the open cell system with all the air, it's highly energy efficient to retain heat as an insulation or cool.
Correct.
Right? Think about being in a cave or in a castle. If you ever travel Europe, it's always nice and cool when you walk into the castles or the churches here.
Correct.
Which I think is amazing. And then the other one was it's environmentally friendly. It's healthy. It's not going to cause allergies or health problems. But then we'll get into the other stuff because there's a lot more to this. So did I hit on those?
Yeah, correct. A solid house keeps the value of your investment, which is also important. The lifespan of a brick wall, if you maintain the building, is everlasting. Really, it's not a fairy tale, because there are examples in the world where bricks exist since thousands of years.
We drove by some here.
Yeah, we drove by some in Wales. You have seen that. So that is a big advantage of the brick, because it really, if you maintain it, it's the same with everything. If you maintain it, it lasts forever.
Yeah.
And it's good for generations.
It is great for generations. We're going to go through the top 10 here, but I'm going to add a couple to it, right? Because like you said, it's fireproof.
Correct.
It does not, it's already been burned or heated up. It's fireproof. It's insect resilient, right? No insects live in it. They can't get in it.
They don't like it.
They don't like it. When it's put together, it's airtight.
Correct.
Build it right, build it tight, as we always say. There's just the properties and the values go on and on and on. And believe it or not, using the red block system, you're not spending more money building with this system versus like a light frame wood system or a timber system. And the house is solid. And just so everybody knows, outside of the house, inside of the house. It's not this way, it's this way to this way. This is the larger block system. This is the one, I think I figured out the math, it's about 19 and a half inches.
Correct. So we already mentioned some of the points.
Yeah.
So here, point one is that it keeps the value. What would be the right word for that?
It maintains the value of the structure because it can't rot, because the insects
Yeah,
can't
and
eat
because
it.
it lasts forever. Number one would be that brick construction maintain the value they have because they don't rot away, they don't, whatever happens, nothing reduces the value of your investment as long as you maintain it, which is the same with everything. The second is it lasts, as I already said, it lasts forever. The lifespan of a brick masonry is endless, more or less. Number three is the insulation value. You have got very good insulation values. For example, for this block, as a monolithic block without any additional measures, you have a U value of 0.15, 0.16, which is also, you also can build passive house with that. I don't know if this makes any sense for American market.
I think from the passive house, the U value will not, because we do everything based on an R value, right, with the thickness of the walls. But I can tell you now, being that it's airtight and without any additional insulation within here, that it meets passive house standards, and European building practices are typically stricter already than what we have to do in the United States. That's impressive.
The next one is the behavior against noise, acoustic behavior, where bricks are very good because to have this protection against noise, you need mass. And bricks, as you said before, have mass.
Yes.
So 1 square meter of this block is 320, 330 kilograms, and this is noise reducing.
So to help people understand that, if the noise hits on this end, for noise to travel to the other end, it has to go through this whole maze of lines to get there, and it slowly just makes it go away on the way in.
The next point would be the fire resistance.
Yeah.
The brick already went to the fire for you, so it cannot burn, which is also a big contribution to safety. Yeah. Because if, fires always happen, no matter where, but then it depends what all starts burning. And if the wall starts burning, then it goes very, very quick and you have very low time to get out of it. In a brick house, the walls don't burn, so the most what is around you is not burnable. And this is a lot of safety built in.
Not only for the occupants, but for the firemen that have to come.
Correct. That's very important. Mm-hmm. Then next point is static. So bricks take the load, are load bearing. We call them load bearing bricks. Mm-hmm. They are very good in that respect. So with bricks you can build up to 6 to 10 stories high without any additional measurements. Depends on the kind of brick you use.
Yeah.
But that is possible.
So I can go up to 10 stories high, depending on with the brick, but the average is somewhere between 6 and 8 that we see.
Here, the average is between 4 and 6.
Between 4 and 6, okay.
This is the average. Yeah.
But this can also be used on commercial jobs as well as in skyscrapers with a layer of concrete and pillars between, right?
In skyscrapers, our client in Russia is building high-rises up to 25, 30 floors for apartments.
Okay.
There they have structural measures to build those high-rises. That means they have concrete pillars, and in between the walls are made of brick. Yeah. So also this is possible. Yeah. That's also an issue for extreme seismic areas, because that's also not an issue in Austria, but in many other countries. Look at Turkey. There it is an issue. And we are also working on that, and we are doing research on that. Also in WOSH, we have some very interesting approaches in that respect.
Look at Los Angeles. There's a perfect example.
Yeah,
right?
correct.
Or
San
California,
Francisco, California in general.
Yeah, for sure.
The next issue or the next point would be the room climate. If you are in a room, you have a very good room climate, which means in terms of temperature, moisture, sound reduction. That is, the room climate actually is the result of the sum of the other properties of the product. And that is one of the best. Of course, it's airtight. That is also important, especially in terms of energy efficiency.
Yeah.
I wouldn't say it's a cheap way to build, but it's a very cost-effective way to build.
Right.
Also because it lasts so long, but also if you compare it to other construction methods, it is still one of the cheapest methods to build a house.
Right.
And that's important too. It's ecological friendly. We are taking our raw materials regional, we are producing it regional, we are selling it regional, so we are fulfilling the demand which we have here in the area. I would say 80-85% of our production get transported maximum 35-50 kilometers. So it is a regional product that is made regional. Yeah, that would be would have been the 10th discipline where brick is very good in. There is one thing which we didn't mention now, but it has to do with the room climate. The brick has the lowest equilibrium humidity of all building materials. We talked about this Norwegian pullover.
Yeah.
That works very well as long.
It's like a big sweater you pull over. It's
a
thick.
Big sweater, thick, holds you warm in cold if you're in Norway.
Yeah.
If you put the plastic over that and you start, let's say you start sweating, you will freeze like wool, transmits the cold towards you. So therefore it's very important that your Norwegian pulley is dry. Then it keeps you warm. Same as with the brick. And the brick has an equilibrium humidity of 1%. That's the lowest value of all building materials. And therefore also the insulation values are stable, long-lasting, and you have them forever. Other constructions gather humidity or don't even get down to a very low equilibrium humidity, and therefore you have more water in here. Norwegian pullover, wet.
So
and you know what the outcome is.
So let's talk about that moisture control, right? Let's say this is the exterior of my building. Just like any building, I'm gonna, I can put insulation. If I want to put rock wool against this, I can put it right against this. If I'm gonna do a siding that cannot breathe, whatever that may be, I gotta kind of leave a little bit of a gap, a 1-inch, 2-inch gap, which makes sense. We do that in regular passive house or net zero building the way it is now. But let's say water from the inside let's say water from the outside actually did get behind the siding. What does the clay block do, the clay brick, do with that water? Do I have to worry about it coming all the way into my house?
It will. If you soak the brick, the brick has a water absorption of 30%. If you put it in water, it soaks it.
Right, but that's usually not the case.
No,
with the rainfall.
No, this is then you have a mistake in construction if you have that case. So actually you're putting here either a plaster on this kind of block. You only have plaster inside, plaster outside finished. So you don't have an additional facade or whatsoever. So you put the plaster on the outside, and then it's protected against rainfall. Even when the rain comes with strong winds, it doesn't get into the brick. The important thing what the brick is doing is it equals the humidity values between the inside and the outside. And this is what we are talking about, diffusion openness. So we say in construction there is a rule that says you have to get from the inside to the outside, you have to get more and more diffusion open. So you start with something that has, let's say, a value of 1, and the next, if you have a next layer, then this should be 2, and if you have another layer, it should be 3. The openness should always be more from inside to outside, because then the brick can take the higher humidity which you have indoor, because you produce humidity indoor by breathing, by cooking, by washing, by drying, whatever you do in the house is you produce some humidity. Brick takes the humidity and transfers it to the outside. And still, and this is the important point, still keeping this 1% equilibrium humidity. That is the important thing. And that guy is the only one that can handle that.
The only one that can handle it. So when we're talking about a block system, we're talking about a clay porcelain system, not
Correct.
concrete or,
No.
right, the clay porcelain, which you see being built all through Europe.
Yeah, but this is a different story.
Yeah, yeah. So it actually controls the moisture from the interior to the exterior of the home.
Correct.
So long as you use the right barriers as well. There's a science behind it. You just can't slap anything on this. You have to use breathable,
Correct.
right?
Exactly, that is the point.
Materials, which are already using in construction now. I mean, to me by itself, when you look at this, I mean, like you said, there's 10 values to this one block. So we're doing several things here. One, we're reducing the amount of labor we need to install because now this is the system. We're reducing the amount of skilled trade because we're all lacking skilled trades by not having somebody having to staple a vapor barrier or tape a vapor barrier all on the exterior of this as well. We're reducing the need for pest control on site. Let's talk about the longevity of the home. That falls into the maintaining your value because you don't have to worry about that.
We don't even have the job pest controller here in Austria. That job doesn't exist.
So if you're in the pest business, Austria is not your place.
It's not the place to go.
It's not your place to be. Right, right. And if it does get wet, like flooding, we did talk about this, it naturally will wick away and dry over time.
Correct.
If you're in a flood or something happened.
Yeah.
But if you're building in a flood nowadays with the knowledge and technology we have in a flood zone, well, you know, that always makes me question. But some people don't have a choice. That's where their house is, and they have to do something.
Weather is changing.
Yeah.
We all
It is changing.
experience that. So areas that were not flooded, flooding areas in the last centuries now turn to be flooding areas. Right. It's also our fault because we tried to control rivers, we tried to control flows, we did a lot of things, but there is an old saying: whatever you do, do it complete and think about the result.
Yeah. Right.
And often we didn't think about the results, and this is the price we have to pay now, unfortunately.
Yeah. And that is true. So Markus, tell me about the reduction in the CO2. I mean, we have all these new energy codes coming out, not only in America, but around the world. I'm sure you have them here as well. What is the, brick industry doing, in particular? I mean, you've been in this forever.
The first steps we already made long before CO2 was an issue. Because in our plant in 1972, we changed from first coal, then oil, to gas. And gas is, from the fossil energies, gas is the cleanest in terms of CO2 emissions. Yeah. And we did that already in 1972. Mm-hmm. And of course, it is a cost factor on one hand, and it's an ecological factor on the other hand. We try to reduce our energy consumption as much as possible because that costs money. Yeah. No matter if we use it as electric energy or if we use it as fossil energy in terms of gas, it costs money. So it is in our own interest to reduce it as much as possible. But still, we have to make our product. So we need energy. The question is, what are the sources of our future energies? Mm-hmm. What are the sources now? We know. We have gas from the pipeline, we have electricity from the power plants. But in terms of electricity, I told you, we already produce, if the sun is shining, 80% of our electric supply for the production of the bricks, we already produce ourselves with photovoltaic. Yeah. I have the plan to increase that number, to even make more. We are coming up to almost 1 megawatt now. With the photovoltaic production. So that is something we are working on. Mm-hmm. And in terms of burning the brick, there are different approaches, but none of those is already, let's say, on an industrial scale. Yeah. So we are thinking about using renewable energy, like biogas, for example. We are thinking about hydrogen. But for hydrogen, you need first the production plants that produce it. Yeah. We cannot step, as a brick maker, we cannot step into, or it's very hard for us to step into the position of being an energy producer.
Right.
because this is a complete different job. It's a bit different business.
Right.
We depend on that, what comes out on new technologies on the market, and we have a very close look to that. And we are also urged to have a very close look on that, because our CO2 emissions, which we have, everything is controlled by the state, by the European Commission. So, and we have to reduce it every year, year by year by year by year, until 2050, where we have to reach a zero emission production. There are already some prototypes in construction, and they will get operational within the next 1.5 to 2 years. I'm very much interested in that, what's coming out there, and this will lead us the next way to our next step. But everything also has to be brought into a relation.
That's right.
And you asked me today, what is the emission for a one-family house in terms of CO2, of fossil CO2?
Using this product.
Correct. Using this product, there are like comparisons. When you fly from Los Angeles to Munich and back, that is about, you have the same CO2 footprint as you have for a brick house.
One plane to Munich and back.
No, not one plane, one person.
One person.
One person. If you fly from LA to Munich and back, you emit 6 tons of CO2 as one person.
And so my plane had like 500 people on it.
Yeah.
It was huge.
One Airbus, yeah. And in a normal annual operation, emits more than the whole Austrian brick industry in 1 year, which builds 60,000 homes.
And you take that a step further and you get the manufacturing also completely reduced.
Yeah, we have to. We are obliged to. We have to do it, and we will work on it. But as I said, we are dependent on upcoming, not theoretical solutions. We need real solutions in order to be able to produce our product. And there are technologies, but they are not, as I said, on an industrial stage up to now. We have to work on that, and this is also, in my opinion, this is the responsibility of the society, of the states, of the governments, to bring up that basics infrastructure that we need to fulfill our job.
Yeah, and from what I've seen on this tour so far, that's becoming more of a reality than a theory, so we'll wait and see, but still got to put it in full practice and test it and make sure it works, and hopefully next year we'll have that on the show as well, because it's pretty cool stuff. Think about it. We get to take the sewage sludge that we all create as humans and turn it into something good, not only for the factory, but it might be feeding the plants and everything else out in the field. So super cool stuff. Markus, let's talk about the next generation. We have the block, we have all the energy efficiency, we're reducing the CO2 footprint, we're working towards meeting the 2050 goals. We have a wall panel system for offsite, so you don't need strong guys and men or whatever lifting these anymore. Anybody can do it because we're using technology to lift. However, it's still a block wall. But that block wall is now becoming more and more advanced, and you and WOSH, the team of WOSH, is looking with other partners to fully integrate MEPs into the wall system. Can you talk a little bit about that?
When I met Osama from WOSH the first time, he already had this idea of a general production plant for a house. He already had this on his mind. And when he learned about Red Block, he said, this is one part, one puzzle, which I need to get there where I want to get. And he brought different branches together, which are leaders in their field, but they are doing their job. So we are doing our walls, others are doing ceilings, the next ones are doing foundation plates, next one are doing facades, the next ones are doing maybe even complete bathrooms, name it. His approach was that he has to bring this under one head. This is not so easy as it sounds. It's,
Very complex, and an
It's a
industry
very-
that doesn't want change.
correct. That's the biggest problem in that field. And he made a very smart move, in my opinion. He went to the well-known RWTH University in Aachen in Germany.
Yeah.
This is one of the best-known university in terms of building technologies on one hand, but
In the world.
In the world, they do research if there are big reclamations somewhere on a construction.
Yeah.
Mostly those people are going there as experts.
Yeah.
So they have a huge knowledge in this field, but they also have an enormous knowledge in Industry 4.0 in terms to bring all together, the software, the logistic, everything, to make it one. We needed those people because they know how to do something like that. We didn't have the experience and we didn't know how to handle that, so we needed this professional support from their side. And they're already also part in that WOSH group, let's call it. And every partner in WOSH is working on his field, but always looking at the other fields. We get one piece and not many pieces. And this is WOSH. The end of WOSH should be, this is our vision. The end should be that we build a plant somewhere in Europe or maybe in America, I don't know, where we build one plant, and from that plant we do almost a complete house finished on an industrial scale and just bring it for assembly on the construction site, period. This is our vision.
Yeah. Well, the assembly part makes a lot of sense, but so does the manufacturing part, bringing it all under one roof.
Yeah.
You know, when we look at a job site now, the wall panel shows up, the electrician shows up, the plumber, MEP, they all show up separately.
Correct.
And with the lack of skilled trades, we need a more of assembly approach versus a skilled approach on the job sites. If we can bring all the skill under one roof, then it's going to make the process on the job sites that much more efficient, and the people that are putting it together and assembling on a job site more efficient. You know, the whole concept of WOSH, I really like how you said that, because what WOSH has done, it has brought the experts of the industry. I mean, come on, you first one to bring robotics into the brick space. Think about this. Brought the experts of the industry all together to formulate a full, complete manufacturing and assembly system for the walls and the components under one roof. Not just block, not just the wall, but the MEPs, the electrical, the climatic floors and ceilings.
Yep.
All of this coming together, so when it leaves the production on the truck, it only needs to be assembled on site, which is going to speed up that process as well and get people in homes faster. But like the auto industry, if we can control the manufacturing side of it, we can reduce the cost of what happens out in the field, which also makes it more attainable for the average person to own a home and to get in a home.
That's correct. And you reduce the error rate by far.
Right. Right. You know, this is, to me, you know, a huge advancement from where we've been going, right? And when I mean that in the concrete and block space, to be able to bring the experts together to actually design a system that can all talk to each other, right? Because that's bringing it under one roof is one thing, but how do you get all these systems to communicate has been the other challenge, yes?
Exactly that.
And WOSH has been working on all of those connecting points to put this in place.
Correct. That's exactly what they do. And the outcome, as I said, should be one production plant. You know, we also made the decision that we are not going into volumetric building. Because as soon as you go in volumetric building, you have to face the fact that you are limited by transportation.
That's right.
From the plant to the site.
Yeah.
And you are carrying around a lot of air and
extra permitting costs, everything.
And huge things. maybe in the States that's easier to handle because you have this wide open land, this wide streets, where you can even put a house on the trailer and then you ship it somewhere. That works. That wouldn't work here. You just I go 500 meters and the next bridge stops me. So.
Right. Yeah, modulars even in the United States can't work everywhere. It's hard to do in cities and smaller areas or older towns.
Yeah.
I don't think there's a big difference between there and here, other than you have much smaller streets to get around.
Yeah, it's a little bit.
Well, what am I missing on this concept with WOSH that we're not talking about? I mean, we have all the experts in all the different industries. They've already written a lot of the connecting software to make all this factory comes together. Yeah. The value proposition from our tours and traveling between here and Germany, and we're also going to Italy, is telling us that the value proposition from a cost perspective can and is no different than site building today or panelized building.
It will be cheaper.
But you're living in a solid home.
If we really achieve what we want to achieve, it will be cheaper.
Right. And I don't have stud after insulation, air barrier here, vapor barrier here. No. I have my block wall. I can add extra insulation to it.
If you want.
You can fill it with insulation.
Yeah. Another fact which is also important, if you are a masonry worker and you work with these or different kind of building blocks your whole life, you know how many tons you are lifting?
Oh yeah.
You know, that's going into your back.
Yeah.
So it's also good for the health of a lot of people, because usually in times like this, we shouldn't be obliged to carry heavy loads around day by day by day by day.
Yeah,
that's
right. Well, the systemized approach opens the workforce up.
Correct.
To
the quality of the craft gets raised by far.
Sure. Yeah. This is a clay material that turns into a ceramic in the kiln.
Correct.
It's readily available. I'm finding out that the manufacturing of this, like the Hurl plant that we were at in Dachau, Germany, has been there for a long time and can stay on that same piece of land for another 300 years plus. Not making their footprint much bigger than it already is, because they have all the natural resources right there. In the United States, do we have the same amount of material and clay?
Definitely. You have very, very good ceramic clays in the United States.
Yeah.
And they are maybe even in quality, in terms of quality, way too good.
Right.
So, as I told you, we are also mixing different kind of raw materials to reduce the very good ceramic behaviors of one of our raw materials. So you will have that materials all over. If you go to, Carolina, North Carolina, South Carolina, over to Texas, no matter where. I've been in brick plants, even in Salt Lake City.
Yeah.
And they produce bricks there, but they produced facing bricks and not the kind of cavity blocks that we are producing.
Mm-hmm. Markus, I appreciate you having us come to your manufacturing facilities today. I appreciate you taking us to the job sites that you took us to. And I really appreciate learning about the value of this material, because it is sustainable. It is healthy. It's everything that we talk about on a lot of our shows now. And you're taking an old technique and you're modernizing it, and WOSH is even modernizing it even more. You took it to a wall panel.
Correct.
Because you had a vision on how we have to do it better. And now you're working with the team at WOSH to make this an even bigger value proposition to not only here in Europe, but the world.
That is the plan.
I love it. Thank you so much.
Thank you.
There you have it, everybody.
Welcome.
Yeah, Markus, thank you so much. Markus Pichler. We are in Wels, Austria. And that's a wrap, everybody. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.